dreamed of having your online business to make money from the comfort of your own home? Well,
Right. YouTube Live is given access. YouTube Live is given access. Mhm. Right, then we have to wait. This is free for everyone. I had to touch up my appearance now. This one, okay. This one better. This one good. Right. Where are these people? There you go. Share this link to your friends, huh? This is not just a meeting. Again, not just a class. But it is something else. Let's start in another 1 or 2 more minutes. Okay. Can you hear me? You can hear me, right? You guys can hear me, okay? Let's start then. It's 10:01. The recording is there. Anyone can watch it later. Okay, right. Okay. So hello there, people. The people who are new to our class, people who are already coming to my class. So I am like Tharuka Rajapaksha. I have shared the posts and everything in the group. Rankers Club admin, right? So today we have this interesting MSQ thing which we are doing. Correct? එතකොට today we just have few questions or a few questions. Can you first in it? Like okay, MSQ1, right? This is MSQ1. When we go step by step further, one by one, we'll go. We do something complex like inorganic statement questions. In kinetics, we have right theory questions, A plus points and stuff. And then electrochemistry calculations we can do in MSQ, right? So this is free for everyone. Anyone can join to this and complete certain theory parts. එතකොට question practice ගන්න ඕන you have to complete the MSQ. එතකොට MSQ stands for the midnight statement questions. එතකොට මේ වගේ එකක් only I guess I'm doing in chemistry in Sri Lanka English medium. Right? එතකොට this is just a milestone for the beginning for this series. හරි. එතකොට මේ YouTube live එකකුත් තියෙනවා. YouTube live also there. ඒකෙනුත් බලන්න පුළුවන්. හරි. මේ I put the Zoom link mainly for students who are coming to my class. They can ask questions directly here. So I created it. Where are the others now? Right, I'm gonna start now. Right, I'm gonna screen share Word. Can you see my screen, people? Can you see my screen? I hope you can see. You should see, right? Yeah, can see my screen. Afra is you didn't come to today's class, right? Didn't come to today's class. But Afra means that person from the revision, right? There are so many Afras I can't recognize. Didn't come to the class, right, today? What happened? I don't know whether it's you or not. Maybe I'm asking from someone else, right? Whatever. Okay. Hi. First question. Goal is experiment done by Rutherford using alpha particles. Now, what is this alpha particle thing? Online. There's another Afra physically, I guess. Yeah, she only didn't come. What is this alpha particle thing? Like Rutherford was like taking a gold foil. Think of this as a gold foil, will you? He shooted like alpha particles from this side. He shooted out alpha particles. According to certain people's knowledge, what happens is it should bounce back later. Like it's a gold foil, it should bounce back. But what Rutherford observed was like not like that. Most of these alpha particles penetrated out, and some were like bouncing off like this in this direction, this direction. Some are like going in this direction and this direction. That's what Rutherford observed. Now, why does this happen, right? Now, why does this happen? ඒකත් බලන්න එපා. Right. එතකොට මේක අයින් කරන්න ඕනේ. හරි. Now, why does this happen? You know, when you're playing cricket, there's a bat, right? There's a bat like this. Nice bat, right? When a ball is coming towards you, if you angle the bat in different directions, you can change the direction of the ball, right? That is what's happening here also. Like the nucleus, there's something called nucleus. That's what Rutherford said. There's something called nucleus, and there is an empty space. Very nice ball. Right? So there is a empty space in an atom, he said, like wrong and in the way, like this. So an alpha particle is like coming, and if it hit straight away, then it's going to bounce back. But if the alpha particle came and hit like this, then it's going to bounce that side. Ne? If it move through here, then it's going to go undeflected straight away. It's going to penetrate, right? So this is what Rutherford said, right? So Rutherford identified like this is happening because mass is concentrated at the center here. Mass is concentrated at the center, and the rest of the alpha particles are going through the space. Right? So he concluded that most of the atom is made of an empty space. And he said like electrons are rotating in that empty space. You know that Rutherford's planetary model? Rutherford's planetary model said like the mass like is concentrated in the center. The positive charge is concentrated in the center. That is what Rutherford said. Right. Now let's look at the question. So look at the question again. Here, the gold leaf experiment done by Rutherford using alpha particles explains that number one, atom consists of electrons. No. Atom consists of electrons. J.J. Thomson who found electrons. එතකොට මේක ඉන්න. Actually, it's an ABCD type question. මෙහෙම එකක් ඉන්නේ ABCD type question. I just wrote 1, 2, 3 for you. I couldn't edit it. Second statement, the mass of the atom is concentrated into a point and the volume of it is very small. Correct. That is correct. The mass of atom is concentrated into a point and the volume of it is small. Relative to the atom, the volume of the nucleus is small. Right? Correct. Then third one, the atoms are building unit of matter. Atoms are building unit of matter. Actually, Dalton said it. Democritus was the first to say there is a building unit called not atoms. Actually, he said atomos. The ඒකට precise definition was given by this Dalton. Dalton gave a precise definition for this, and he said like atom. He said atom. So this was done by Dalton actually. Neutrons are found in atoms. No, neutrons තියනවා කියලා හොයාගෙන නැහැ. Rutherford didn't know there are actually neutrons. He just said like the nucleus. The mass is concentrated at the center called nucleus. Just the nucleus. He didn't know there are neutrons or protons. He just only knew there's a positive charge at the center and electrons already found. Electrons are rotating around the center. That is what he said. So this one is also false. So answer is answer number 5. Haribu, answer is answer number 5. Okay. People tell me, did you understand? Interactive session. Now then this is an interactive session. I want you to communicate with me. Right? I want you to communicate with me. There is this people. Some people have no current. Fine. Right. Okay. How to erase this now? First one, answer 5 then. Na? For first one, answer 5, how can I make it? If I do this, I can do this. What is happening? Answer number 5. That looks better. Eh? Answer number 5, only B statement is correct. The thing is like in Zoom annotation, if you draw something and then you scroll, your screen is moving with it. So that's a problem. Look, see? That's a problem. Hari. Second question. Atom was first articulated by. Again, atom was first theorized by whom? Actually, Dalton මෙතන අර Democritus की කතාව දීලා නැහැ මෙතන. They haven't given a Democritus thing. They have given Dalton, so definitely it should be Dalton. The I gave a note to everyone of you. Harish podi short note එකක් දුන්නා. ඒක refer කරන්න පුළුවන්, right? Right. එතකොට ඒකට උත්තරේ දෙක easy question. Easy question. I have included some easy questions here. In worksheets, I have included some tough questions. මෙතන easy questions ටිකක් දාලා තියෙන්නේ. MSQ 1 meeting පවුනේ, right? Your innocent people. So I gave easy questions for that part. Right. How to scroll down. Now, this third question is interesting. Now, this one I didn't give in the revision to it because I wanted to do it through a question. Right? How to do that now? How to do that now? Look. The question says there is carbon 612 thing and there is carbon 13, 16. These are isotopes. Actually, there is another one, carbon 14, but it is very less. In the last lesson of physics, you learned carbon dating, carbon going on dates. Right? In carbon dating, we have to deal with something with this. In this question, they haven't given it because this is negligibly small, very small, right? So this one we have ignored in the question. Only these two are given. Right? Only these two are given, right? Like how to find the relative atomic mass using these values? They have given. Yeah. Naturally occurring carbon contain 98.89%. And make what they have done. Now fine. See, 98.89% of C612. Let's write that 98.89%. 98.89. I'm using a mouse, still hiding by a writing pad. 98.89% of that mass. Actually, now we are finding the molar mass of a compound. Molar mass of a compound is actually the average of both. You don't add them and divide by 2. We are trying to find with a percentage like 98.89% of 12s, right? The mass of 12, I mean mass of C612 atom, it's going to be 12 grams per mole, right? So 12 grams, this much is there. Then remaining, it's like 1 point something, 1.11%. 1.11%. You add that to here. 1.11% of 13. That is how you do it. This is an equation. This is very simple. Very simple. The theory students, sorry, not theory students, revision students, make sure you write this clearly behind your note or somewhere in your unit 1. That is a make an important maker. I didn't give that in your tube because I needed to do it through a question like this. Here you go. This is how you do it. To make a simplify karama, you will get something like 12.01 or something like that, I guess. Wait. You are getting actually from here you are getting 11.8668 and 0.1 meter. Just to calculate 11.8668 plus 0.1443. 12.011. 12.011. Then 12.011 will be the answer, right? What will be the answer there? Fourth one is the answer. Did you understand now? Discuss a question related how to find the electronegativity of a compound, because this Monday I have how to find electronegativity of compound, because this Monday I have chemistry third term. Okay, after doing these questions, let's see. Right? So others purpose of coming to the meeting, you go, right? Electronegativity of compound means like in a compound like this name. Compound like you're finding electronegativity like carbon, nitrogen, hydrogen, right? Electronegativity variation, that thing you are saying me. That is the thing. එතකොට ඒක කරන්න තියෙනවා priority order එකක්. ඒක බලමු. Right? Okay, this one answer 4. Third question answer 4. Then fourth one, that one easy. Physics. You learn this under electric fields. Which of the following gets deflected when moving in a magnetic fields? You learn this. Which of the following gets deflected when moving in a magnetic field? Very easy. Neutron cannot get displaced by this. There is no charge in it. Cathode rays can get deflected. Protons can get deflected because there's a charge in it. Helium atom is a neutral thing. If it was helium ion, then it will deflect, but here it is helium atom, so it will not deflect. So B and C answer number 2. B and C answer number 2. Right. Fifth question. Number of electrons and number of neutrons present in AC, right? Number of electrons and number of neutrons present in magnesium 1225 iron. Now this one related to electronic configuration. You have to write like electron. On it there, right? You can directly take it from here. Right? So in down. Now you have this 12 O level. O level means this is protons or electron number. Both are represented by this one. This is the atomic number. Atomic number. And this one is the mass number. Then you subtract this one by this one, you get the number of neutrons. Number of protons won't change in an atom unless it's a nuclear reaction or something. Number of protons cannot change. Then what you can change number of electrons. Here they have removed 2 electrons. They have removed 2 electrons. Okay. The question what they are asking now. The number of electrons and number of neutrons present. Number of neutrons 25 minus 12. No one can change it. It is 25 minus 12. It's going to be 13. Right? So yeah. So here you can eliminate this answer, you can eliminate this answer, you can keep these answers, right? So 13, 13, 13. Number of electrons. There are 12 electrons. I told you we can take the number of electrons from here. There are 12 electrons. So what's the magic, right? You remove 2 electrons from 12, you have 10 electrons. You have 10 electrons, so it's answer 3. Lazy, right? That one very easy. Now, 6th question. Now, in the worksheet 1 and 2, I haven't given questions related to this, this theory things like atomic theory, plum pudding, Rutherford, J.J. Thomson. These things I haven't given MCQs in the worksheet 1 and 2. So that is why I gave you in this paper, and that's why this paper is easy. Otherwise, it is not easy. Right? Questions, right? So I didn't put there. Worksheet 2 was somewhat difficult than worksheet 1. But this one very easy. This one. Okay. Of the following, which scientists were not involved in the development of atomic theory? What is atomic theory? People? What is atomic theory? Atomic theory means the development of model of the atom, how electrons rotate around protons, how electrons rotate around the nucleus. That's the atomic theory. Who never contributed to it? Who never contributed to it? Can you tell me the answer to this, people? I guess you know this answer. Know the answer to this question. Guys. Answer to this question. Tell me. Tell me. Hey, not sleeping, right? Everyone. Everyone answer. Come on. Everyone answer. Nice. Linus Pauling, ne? Good. And the Pauling, what did he do? He found the Pauling scale, ne? Pauling scale It's like electronegativity variation thing. Again, electronegativity variation. Actually, for different elements, he gave like electronegativity values. So the polling scale like had the linear polling. Ek ivarayita, right? So that is done. How to. The identity of an electron in an atom can be expressed using 4 sets of quantum numbers. Which sets given below is false. Now the revision students will be like they like this question better. Why? I hope you do like this question better. We practice a lot of things from this. This is a past question, right? Let's see. Let's go for the theory value. People who are new to here, let's go to the theory in brief. Let's go to the theory in brief. Look. There are 4 sets of quantum numbers, L, simple L, M sub L, and you have MS. Those are the 4 sets of quantum numbers. Actually, quantum number is a representation of an address of an electron. Like, right? So if you want to hit a missile to certain place in a certain place in a certain place in a world, in the world, you have to give coordinates to it, like x coordinate and y coordinate you have to provide, then only the missile will go and hit to that place. And then only the missile will go and hit to that place. So these electrons in atoms, there are like certain address to each of these electrons. Right? So this n value is like a country, like which country do you belong. The simple L value is like, wait, the simple L value is like the district or something, right? And capital ML value is your house. And same M sub S, I call it M sub S. It's like M sub S, I spell it like that. You can spell whatever the way you want. MSO, ML, 100, right? They won't ask like how to spell this, 100, right? This is like the room which you're in, let's say like that room which you're in. To find you, we have to go to the first to your country, then to your district, then to your home, then to you, right? Then only we can find you. Each electron of an atom, let's consider sodium now. Sodium, I do have periodic table. I had a periodic table. Here. Right? So sodium is going to be 11, the atomic number 11. That means 11 electrons are there. So here you go sodium, first shell 2 electrons. Next shell you have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And the next shell you have 1 electron. You have 1 electron there. Now, if you want to like address this electron, you want to send a letter to that electron there, right? You want to send a letter to that electron. How would you send it? First, you have to describe its location. You go to first the principal quantum number. Simple N means the principal quantum number. Principal quantum number actually means the energy level which it belongs. There's the first energy level. Now this is all level where we have many electrons are placed. This is not the way electrons are placed. You are going to learn that when we go to hybridization and stuff, right? These electrons are like first energy level, capital N, principal quantum number means the energy level. This is the first energy level. That means N equal 1. This is the second energy level. This is third energy level. Then the location of the final electron I want to address of sodium. So it's going to be 3. I'm going through a brief explanation on the revision class. I did a perfect theory on this, right? So metana I'm doing only a revision. Revision, make it revision, right? Revision Ultra Pro Max, right? May L value. You can write it like L value is less than and equal to N minus 1. This is an equation which you have to remember. When N equal 3, what are the possible values for L? That is how you say it. Like when N equal 3, what are the possible values for L? That means it's going to be 3 minus 1. It's going to be 2, right? So you have 0, 1, 2. What is 0? 0 means a s orbital. 1 is a p orbital. 2 is a d orbital. So there you go. These are the 3 L values that a n equal 3 can have. Imagine now n equal to means what? N equal to means L values can be either 0 or 1, right? It can be 2, right? L is less than and equal to n minus 1. Less than and equal to n minus 1. That is okay. M sub L values. Now you have to identify which orbital does it belong. Is it s orbital or p orbital or d orbital? Where does it belong? We have to find it out in the periodic table you have. It is thorium's last valence electron is a s orbital. There's another equation which I remember, like let's say the electron here is the s orbital. Actually, it's the s orbital here, right? How do you find it? The periodic table, you look into that and then you can find it out. That is a, okay. So there's an equation like m sub L is equal to minus L to plus L. Some theory notes don't have this. Make a සමහර note වල නැහැ. ඒ කියන්නේ students should think and take this. ඒත් එහෙම ඕනේ නැහැ මේ equation එක තියෙනවා, right? Minus L plus L. Now tell me if L equal 1, what are the possible values of m sub L? It's going to be like minus L to plus L. It's going to be minus 1, 0, plus 1. Minus 1, 0, plus 1. That is that. When L equal to, then හැමතැනම ලියනවා නේ. කොහේ ලියන්නේ? මෙහෙ ලියන්නේ. When L equal to, what are the possible values? Minus 2, minus 1, 0, plus 1, plus 1, plus 2. Plus 1, plus 2. मैं erase කරන්න. Sunmonite. Right. එතකොට people here the electrons of s, I mean, belong to the s orbital. The last electron belong to the s orbital. So m sub L value is actually 0. Why? When L equals 0, what are the possible values for m sub L? Minus L to plus L. Minus 0 to plus 0. Right? There's only 0. M sub L equals 0. M sub s value means that now you look at a s orbital. This is a s orbital. There's only one orbital. The two electrons are in opposite spins like this. That means this electron, if it is spinning in the clockwise direction, you call it plus half. If this electron, then this electron should spin in the other direction. Again, if one electron spin in one direction, likewise, the other electron should spin in the other direction, right? So it should go like this. Try to do this. You can't do this. Like one hand forward, one hand backward. Try to do it back around, right? Try to do it now. You're at home. Try to do it. You can do this one also. Like do your hands like this. You have to shift your fingers. Like you have to do like this. Tell me in the chat, can you do or not? Do like this. I am saying like this. Keep your two hands like this and shift your fingers. Can you do it? Tell me, people. Can you do it? Hold on. Come on. Nidhi, and can you show again? Then this is going to be a magic show now. Mayhem. You are going to shift your fingers like this. One person can do. all fingers are down. Right. No, right. Whatever. Alright, focus now. M sub S value. Oh god, that's so hard. Yeah, I'm talented. That's why maybe I can do it. People who have the brain can actually do it. People who are intelligent, more intelligent people can do it. People who are people who are, dumb cannot do it. That is what Einstein said. Right? Trust me, that is what he said. Hurry up. Right? People, listen. M sub this value is plus half. Nana Siddharth Einstein also said that. Like people who can do that is very intelligent. They say. Like very intelligent. I mean, supreme intelligence. Yeah, ultra pro max level. Sounds like you're. No, no, no. It's said by Einstein. Ask from Einstein if you go and ask anyone. Like go to the heaven, you will see Einstein. They are sitting there doing something. So you can ask him. I'll see how to give you. Okay. M sub this value minus half plus half. Here you go. Hurry. So that is a basic idea of the quantum numbers. You said me dumb without pointing to me. No, no, I didn't say like that. Who said that? Okay. Hurry. Let's go to the question now. Look, look, look. Hurry. There are four sets of quantum numbers. There are four sets of quantum numbers. So the first one is going to be the n value. It's going to be like n, l, m sub l, and then you have ms. The first one is going to be the n value. It can be 3, it can be 2, it can be 4. Right? Then we are checking the L values. The L value actually should be less than and equal to n minus 1. Then it should be less than 4. It can't be 4 here. So it is this one okay. For now it is okay. This one also fine. Less than 3. This one also can. No problem. This one also can. No problem. This one also can. No problem. We can't take it like that. M sub L values. What is that? M sub L value, actually I told you it can be minus L to plus L. Minus L to plus L. Right? Minus L plus L. Right. What is the L value here? 2. Then M sub L can be minus 2, minus 1, minus 2, minus 1, 0, plus 1, plus 2. Right. That means this one is okay. This one is also okay. What about this one? This is 1. Then minus 1, 0, plus 1 possible. This one also can. This one look below. This is minus 3. Can't be named. This one can't be. Why? Why it can't be? Because this L value is 2 and this M sub L value can't go to minus 3. It should be minus 2, minus 1, 0, plus 1, plus 2. Then this one is wrong. Printing mistake. You are getting 2 answers here. Instead of quantum is false. They're asking the false one. They're asking the false one. You are getting an answer directly here. Let's look at this one. This is plus 1. This is plus 1, right? This is plus 1. So it can be minus 1, 0, plus 1. Right? That make a this one 0, then this is 0 means this is also 0. Why? M sub there minus L to plus L, minus 0 to plus 0. There's no meaning in it. So it is 0. Then this one also right, this one also right, this one also right, this one also right. They are asking the wrong one, so this is the answer. Did you get it? People, did you get it? That some people are like, okay, good. Clear now, very high. This is a question pattern. This is a question pattern. Quantum numbers is a question pattern. Make sure you know quantum numbers. If you didn't come to my class, right? You have to learn it somehow. Quantum numbers. It's a question pattern. Right. Right. එතකොට next. Eighth question. The maximum number of electrons that can have n equal 3 and L equal 2. Maximum number of electrons are they asking. Maximum number of electrons. Equation I told you. What's the equation? What's the equation to find the number of electrons in a specific energy level? What is the equation? People, what is the equation? Huh? People? People. What is the equation? Oh. Ah. Correct. Yeah. 2n squared, like number of electrons in an energy level, you get it like 2n squared. If you use that equation here, you will get like 2 into 3 squared is 9, you get 18. You get 18. So it's false. Why? They are asking n equal 3 and also n equal L equal 2. Now, what do you mean by this? N equal 3 and also having L equal to how many electrons are there? They're actually asking about a d orbital. They're asking about a d orbital. How? Now look at it. When n equals 3, what are the possible L values? L can be 0, 1, and 2. They are specifying only this. So that means it's a d orbital. It goes like this. D orbital 1, 2, 3, 4, 5. I'll take another color, blue color. So how many electrons you can fill? 1, 2, 3, 4, 5. මෙහෙම නෙමෙයි fill කරන්නේ. Don't fill like this. මෙහෙම fill කරන්නේ. හරි මෙහෙම fill කරන්නේ. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you go. This one. Right? This is how much electrons you can fill into L equal to. L equal to means a d orbital. How many electrons? 10. Right? There is no equation like that. Again, make it a you have to have the idea of quantum numbers. The quantum number L equal to what is that? D orbital, the P orbital, the S orbital. You have to have an idea of that. Right? Okay. Here all drawings. Ninth question. Two elements that are liquid at room temperature make inorganic point, but I included this because some classes have taught this under unit 1 also. Yeah, mercury and bromine. Correct. You are correct. You know things. You're good. You're genius. You're not dumb. Right? You're not dumb. Gallium. Mercury. Bromine and mercury, they are the correct answers. Bromine is Br2. Br element can't exist like that in nature. Like Br2 and you have mercury. Those are the answers. I'll tell you something interesting. Now I'll ask you a question. Maybe actually you're learning phase equilibrium, but I'll say this now. Interesting, something interesting. Can you boil water at room temperature? 1 person said no. 2 people said no. Tell me, can you boil water at room temperature? That means 25 degrees Celsius. Can you boil water? No. 2 people, 3 people said no. Can you boil water at room temperature? 4 people, maybe 5 people said no. Water requires 4,200 joules per kilogram. Can කියලා කිව්ව තව එක්කෙනෙක්. Or 4,200 joules per kilogram kilogram. What is that here? That's the specific heat capacity of water. That is the energy needed to heat water by 1 degree Celsius. Heat 1 kilogram of water by 1 degree Celsius. That is the 4,200 joules. ඒක කොහොමද මෙතෙන්ට based on all of it. Physics you learn it under heat. Don't lie. Yeah? You're going to learn it. මෙතන වෙන case එකක් තියෙන්නේ. This is not that. Yeah, one person said like if you change pressure, this can be done. Yes, you can do it by changing pressure. Yeah, external pressure is reduced. You know what is boiling? Boiling means I'll draw this thing bigger. I don't know whether you will understand this now because it's a Zoom meeting and it is midnight and you're sleepy and you might not you might not get this actually. Yeah, correct. Can boil at room temperature if the pressure is low enough. You know, at 0 degrees Celsius, you can boil water. At 0 degrees Celsius, you can boil water. The meaning of boiling means not 100 degrees Celsius. Meaning of boiling means you are like sending these, what you call, these liquid particles, evaporate these liquid particles. Let these liquid particles go to the top. Right? Already it is going. I know already when you keep a glass of water or something exposed to air for a very, very long amount of time, it's going to vaporize and gets evaporated into the atmosphere. You learn this in phase equilibrium, right? So again, when a liquid basin is exposed to the environment, these liquid particles try to go to the outer atmosphere. We call it vaporization. So boil කරලා යනවා means like bubbles forming the thing. Yeah, in a vacuum it can boil. I'll tell you why. Boiling means like think like this. This is atmospheric pressure. This is atmospheric pressure and this is liquid pressure. Right? This is atmospheric pressure and this is liquid pressure. Boiling means when the liquid pressure increases than the atmospheric pressure. Once you pass that point only, it starts to boil. I'll show you a video if you're not sure about this. Huh? I'll show you water boiling in a vacuum. I'll show you water boiling in a vacuum. Wait. Water boiling in a... I won't go much deeper into this, but look at this. We are going deep into this when you are doing equilibrium, phase equilibrium. Wait, people, YouTube video. That was a nice video. But again, I saw a video where a person takes water from a rubber tube at like 2 stories above the water source and it gets boiled up. How does that happen? Huh? Huh? I saw a video where a person sucks water from a rubber tube at like 2 stories above the water source. It's like he's trying to create a vacuum by blowing sucking air, right? He's like sucking air out of the chamber and he's reducing the pressure, right? If pressure එක අඩු කරාම මේ boil වෙන්න බලනවා. හරි? It's trying to boil because vapor pressure is greater than the atmospheric pressure. Like over person's mouth can't do it, right? ඒක නිකන් අර right. එහෙම පුළුවන් කියලා. Try it. Mm, look, look. Here you can see uh, this is boiling at 0 degrees Celsius. Not 0 degrees Celsius. Yeah, 0 degrees Celsius. That means you are reducing the pressure until there is no atmospheric pressure. There is no one above you to stop you from boiling. So what happens is all the molecules will rise. No need heat. When you increase the pressure, it will return back to normal level. Hari, like, enough. Back to chemistry. Where is it? Hari, I hope you understood something from that. Like, more interesting because when I learned it at first, I was like, what the hell? How to boil water at 0 degrees Celsius? Like, you reduce the atmospheric pressure because that is how you define a boiling point. Boiling point you define with a temperature, not temperature and a pressure, right? Not only a temperature, it is also at a pressure. Correct? May ඊළඟ question එක හරි ඊළඟ question එක. මේක දැන් mercury and bromine, what I wanted to say is like this is at the room temperature and 1 atmospheric pressure, 1 atm. If you reduce the pressure, what happens is some certain liquids also start to boil. Actually Br2 will start to boil. ඒක වෙන්න පුළුවන්. හරි, and it will turn to gas. හරි, මේක බලන්න 10th question. Atomic radii. Which of the following has largest atomic radii? Now what is this? Let's see. S2 minus. Now sulfur belongs to the third period. I'll write it as 3. Sodium belongs to the third period. Again, මෙයාගේ එක electron එකක් ගියාම මෙයා actually he is coming to the second period. Second period වයි එකක් තමයි තියෙන්නේ. Isoelectronic වෙන්න යනවා. I'll say you what happened. F minus, like F minus is similar to sodium plus නේ. Isoelectronic. O2 minus. O2 minus is also similar to sodium plus, so isoelectronic. Magnesium 2 plus is also similar to sodium plus. Okay? So it is going to be isoelectron. They have given S2 minus. S2 minus is bigger than everyone because it is in the next energy level. And already it has 2 more electrons also. So that means it is very big than the others. Directly you have your answer. It's answer number 1. You don't have to even look at others. Sodium plus, F minus, O2 minus, Mg2 plus, all are isoelectronic. These are isoelectronic, and this one is the largest. So you came here to learn it. So I will say the variation of isoelectronics also. So variation of isoelectronics, the one with the largest negative charge is the largest size. That's how you remember it, short method. Without any theory stuff, you learn it like that, right? So O2 minus is the largest one here. No, actually it's 2 minus largest monkey here. O2 minus, then you have F minus, then you have sodium plus, right? You have sodium plus, and then you have magnesium 2 plus. Magnesium 2 plus. Make a variation. We learned this on the atomic radii. It is given free. I have given that free for everyone. You can watch that. It is in the resources channel. The link is given, recording link, Zoom link is given. There I talk about the atomic radii variation. එතනින් බලලා හදා ගන්න පුළුවන් අවුල් ටික කට්ටියට, right? Okay. Then which of the following statements are not true? Radius of H minus is larger than that of helium atom. Hari, let's keep that aside. Now I'm imitating you people. Hari, if you see this question, I'm imitating you. H minus is larger than helium. It should be larger, right? Because you add an electron, so the size becomes very large. And I'm going to make a true කියලා, right? Let's take it as helium has the highest first ionization energy of all elements. එක හරි නේද? That variation, hydrogen, helium, lithium, beryllium, boron, carbon, etc. right? hydrogen, helium, right? Hydrogen, helium. Helium is larger than everything else. Look, it is on the top, right? So, helium is on the top. Helium should have the largest first ionization energy. So, what to make high. Fluorine does not show. Now, not. Does now show it. Right? Does now show. Does not show positive oxidation states. Eka hurry people. Why? Fluorine is the world's most, now today also in the physical class I said this thing, like fluorine is the most electronegative atom of this world. uh, if fluorine shows a positive charge, that means like gyra and charter, right? Most electronegative atom having a positive charge is like charter, right? It's not good for him. So it's not good to have positive charge of fluorine. It does not show positive charge. It only has a negative charge or a neutral charge. So they are positive charges පෙන්වන්නේ නැහැ. ඒක හරි කියලා ගන්න පුළුවන් according to our syllabus. Syllabus එකෙන් පිට මොකක් හරි තියනවා නම් ඒව ගන්නෙ නැහැ. In our syllabus, if they give this question, you have to take it as correct. Syllabus එකෙන් පිට තියනවාද කියලා තියෙන්න පුළුවන්. නැත්තෙම නෑ, තියෙන්න බැරිත් නෑ, කියන්නේ තියෙන්න පුළුවන්. It can happen. Some case rarely point එකක් අල්ලන සමහර කට්ටිය කියනවා මේක මෙහෙම තියෙනවා කියලා. But in the syllabus, like, you can't do that. අපේ syllabus එක පොඩ්ඩයිනේ තියෙන A level chemistry means little. එතකොට if you want to do chemistry better than that, you have to do a degree or something like physical science. You have to do ඒකලා ඒ පැත්තෙන් යන්න පුළුවන්. You can do a masters in chemistry. එතකොට you will learn these things. You can take a PhD also. You learn everything according to it. Hari. Fifth statement එක බලන්නකො. Na2 gas show metallic properties. Is it correct? Tell me fifth statement, is it correct? Is the fifth statement correct? නිදාගන්න එපා ඈ. දැන් midnight statement question නේ, right? දැන් වෙලා තියෙන්නේ 11යි 11 is the time. It's true. Yes, it's true. Sodium means a metal, whether it's a gas or a liquid or a solid. It is a metal. Sodium is a metal. Sodium is a metal. The sodium we are taking as a metal, although it's a gas, it's a metal. Metallic properties are O level විදිහට ගන්න එපා, right? O level metal means like you can touch it, you can stretch it, you can තලන්න පුළුවන්. ඒවා නෙමෙයි metallic properties. In A levels it's something else. It's something else. හරි. එතකොට fourth statement එකනේ වෙන්න ඕනේ. Let's look at that. Oxygen minus, you add an electron to that, is an endothermic process. මේක හරිද? මේක හරි. ආනේ මේක, there's something wrong here. O minus මේක හරි. This one correct. Then it should be fifth. Na2 gas does not show metallic properties. ඒක පොඩ්ඩක් බලන්න ඕනට. I created this question, I guess, and I have messed it up, I guess. මේක endothermic තමයි. එක්ක මේ electron එක මෙහා පැත්තට එන්න ඕනේ. Something like that. I have made a printing error or something. මම ඒක බලලා කියන්නම්, right? However, sodium Na2 gas is a metal. Sodium is a metal. It's a metal again. ඒක වෙනස් කරන්න බෑ. You can't change it. It's a metal, right? Which of the following is not true? The first statement එක හරි. Second statement එකත් හරි. Fluorine does not show positive oxidation states එකත් හරි. The answer should be fourth one here. මේක එන්න ඕනේ fourth one. මෙතන මම දාලා තියෙන්නේ මේ electron should come to the other side. මේ O2 minus එක මුලට ඇවිල්ලා ඔහොම එකක් වෙන්නේ. Right? This is electron gain. Electron gain එකක් මෙතන වෙන්නේ. The first electron gain is going to be what you call negative. Then after that it is going to be positive. හරි. එතකොට මේක exo වෙන්න ඕනේ නේ. එතකොට හරි. මේක exo වෙන්න ඕනේ. මේක exo කියලා දාගන්න. මේක exo කියලා දාගන්න. People, this one exo. is an exothermic process. එතකොට හරි. නේ? This one should be exo. Yeah. Hydrogen gains an electron just an A plus point. Hydrogen becomes larger than everything. ඒක අර A plus කියන්නේ ඒක syllabus එකේ නෑ. Hydrogen when it gains an electron it becomes larger than even carbon. ඒකේ එහෙම point එකක් තියෙනවා. ඒක අවශ්‍ය නෑ. ඒක අදාළක් නෑ. ඒක අහන්නත් විතරයි. Hydrogen gains an electron it becomes larger than helium. අර isoelectronic scene එකට අනුව ගන්න එතන. The isoelectronic species the negative charge is going to have a higher radius. Hi. එතකොට the answer is answer 4 it should be මේ එක exo කියලා දාගන්න. එතකොට MSQ එක finish. MSQ is done නේ. Okay, people, how are you? How are you? I found that bonding question with the isomer it was human question. 2012 question මම බලන්නම් නේ. isomerism එක. මේ බලන්නේ. Right. That person asked me to tell the electronegativity variation. Yeah. I can understand your pain. Wait a bit ago. HNO3 තමයි නේ එතන තියෙන්නේ. මේකද ඔයා කියන්නේ? given iso මේක තමයි. Peroxonitrous acid and HNO3 මම class එකේ ගිහුව එක හරි ඒක තමයි. මේ ඒක syllabus එකේ දැන් නැහැ. They have removed it from the syllabus. එතකොට මේ ඒක මම ඕනනම් note එකේ දෙන්නම්. We learn it under HNO3. Under HNO3 it's a special point in inorganic we learn that. එතකොට ඒක මම ඔයාලට කියලා දෙන්නම් මේ in the revision class when we are doing inorganic අපි inorganic we are starting next this month end we are starting in parallel to chemical calculations and we are doing that. Hari, now you call the suffering and everyone who need to learn electronegativity variation and how to do that please stay. Hari, there's a priority order now. There's a priority order in which you should consider. The first one is the Pauling scale. Right? The first one is the Pauling scale. Now I haven't done this in the revision class. Maybe revision class next week again. Right? Pauling scale you should obey first. That means if there is a nitrogen, now there's a phone call variation. I told this in today's class. There is something called phone calls variation. Right? Right? Phone calls variation means like the highest electronegativity is fluorine, FON, phone. Calls means Cl and sulfur, right? The most electronegativity fluorine, then oxygen, then nitrogen, then chlorine and sulfur. And Pauling scale, according to Pauling scale, always fluorine is going to be more electronegative than oxygen. Oxygen is more electronegative than nitrogen. Nitrogen is more electronegative than fluorine. That's the first thing which you have to consider. The Pauling scale. The next one is you have to consider the hybridization. What is the hybridization of that specific atom, right? You then go to the hybridization. You might not understand this because if you don't have the basics, then you can't do this. You don't know what is hybridization, then you can't understand this. In hybridization, you have sp, you have sp, you have sp2, you have sp3. When you go to the top, what happens is S character is going to increase. I'll briefly say this. S character is increasing, that means electronegativity is increasing. Right? So electronegative, you have to write it like this, electronegative. That means let's take carbon triple bond, carbon, there's another carbon here, and then hydrogen, let's say. We are considering this carbon. This carbon is 1, 2, that means sp hybridized. There's another carbon here who is like this. This carbon. This carbon 1, 2, 3, 4. That means sp3 hybridized. So may I sp3? May I sp? Again, we are going into the priority order. So the first we are looking at the falling scale. Falling scale you can't take because both are carbon. Then no clue. You have to go to the second one. Second one is the hybridization. Then this carbon is sp hybridized. This one is sp3 hybridized. That means this one is more electronegative than this one. The maker don't go to the exam just by using this. Again, maker again. This is just a online session at night making under amaru within, right? You have to do a theory for that. Some theory and question practice you have to do with the time. For now, I will tell just hurry. After hybridization, if hybridization is also same, then we have to then go for the charge. Right? You have to then go for the charge. Change any charge. Charge. Right? Charge means if an atom has a positive charge. Now think there is an atom A who is S, who is like this. Atom. There's another bond like this, and this one is positively charged. There's the same atom on another element or something like this. That one has a negative charge. So more positive means it has the more ability to attract electrons towards it. That means it is more electronegative. When you have positive charge here, what happens is like it can attract more electrons, so the electronegativity is high. So when the charge is more positive, if there is a charge and the charge is more positive than a negative charge, then that is more electronegative. The fourth one you go for is the oxidation number. After that, you go for the oxidation number. Oxidation number. You find the oxidation number of that atoms, and you're going to find the answer after that. Why? Because you check the Pauling scale and it is same. You check the hybridization, it is also same, sp2, sp2. Then you check the charge, there is no charge, both have zero charges. And or else both of these atoms have +1 charge. And same charge, we can't compare, right? So then after that, fourth step, oxidation numbers. Then oxidation numbers, highest positive oxidation number will have the largest charge. Highest positive, largest electronegativity. Yeah? Largest positive charge, largest electronegativity, right? Than the negative. Right. එතකොට ඒක තමයි basic variation එක. ඒකට ওই ටික ඔක්කොම equal වෙලා ගියොත් එහෙම we look at the terminal atoms. ඒවා rarely තමයි එන්නේ, right? That one comes very rarely, terminal atoms. Now the people who come to my revision class and everyone track පයින් දෙපා, right? මේවා කරන්න order එකක් තියෙනවා. There's a specific order in order to do these things. In the revision tube, I have given it like that. First, you need to learn Lewis structures, then resonance structures, then finding hybridization. Then before that, BSCPR release, then finding hybridization, then finding S character. And step by step bond angles. Order එකකට යන්න ඕනේ නැත්නම් මේක කියලා වෙනවා, right? ඒක හරියට කරන්න දෙනවා තමයි කියලා වෙන්නේ. හරි. ඒකට කියලා වෙන්නේ නැතුව කරන්න ඕන නම් you have to do that properly in a class. That is a basic variation which you need to know. There are special points and A+ points. I won't go through them. Right? About your exam was you told on Monday. I think that. If you don't know this variation, that means you are not going to. I don't want to say it, but not going to score much. I think, right? මේක පොඩ්ඩක් අවුල් කියන්නේ එතන ලොකු අවුලක් තියෙනවානේ, right? So you have to go from step by step you have to develop. එක පාට සති දෙකකින් එක දවසෙන් දෙකකින් ලකුණු ගන්න බෑ. Your marks variation will be like this. If your marks is around 40 or 30 or something, your marks will vary like this. මෙහෙම ගිහිල්ලා මෙහෙම මේ හරියට ලකුණු ගන්න අමාරුයි. After you go to 80s, after that getting marks is hard. Here also increasing marks is hard. The initial amount of work which you have to do is very large and the progress is very less. And then at this point, confidence comes. At this point, confidence. Why confidence? You have worked and then you have increased your marks until 40, let's say. ලකුණු 10ක් වැඩි වෙලා. Like I have increased my marks from 10 or 20, maybe this one is 50. Right? After that you gain something called confidence, then no one can stop you. Then you can skyrocket into 80s. Right? Then you can skyrocket into 80s. මෙතෙන්ට යන්න අමාරු නෑ chemistry වල. Although it is hard in physics and bio, chemistry වල මෙතෙන්ට යන්න අමාරු නෑ පට්ට ලේසි. හරි? For an A-level paper, reaching this target is very easy. You just have to know the correct way of reaching there. Our revision class again, we are doing it like this. We do unit 1, right? Unit 1, unit 2, you are ready for the first structure essay. Structure essay 1. Make a unit wise revision class. This is exam oriented. Structure essay 1, you perfect it until you are 100% okay. Right? So to make a structure essay 1 practice එක මම free YouTube එකේ මේ විදිහට හරි YouTube මේ board එකේ ඉස්සරහා හරි කරනවා. ඒකට එන්න පුළුවන් හැමෝටම. ඒ කියන්නේ structure essay 1 I'll take from 2010 onwards to 2024. Structure essay question 2023 actually. 2023 I'll take the structure essay question number 1 and I will do it again and again for you guys. අර මුලින් ඉඳන් අගට කරගෙන යනවා, right? Special points I'll highlight and those things. එතකොට inorganic පටන් ගන්නවා at this month end. After doing inorganic, you can do the structured essay of inorganic. That means structured essay 2. We perfect it 100%. Then you have the essay part, right? You have the essay part. Ninth essay, you have A part and B part. B part is somewhat regarding calculation. The calculation also we are doing parallel to inorganic. May essay may structured essay. Also there is the seventh question B part. The A part is electrochemistry, B part is B block. Right? Within next month, that means February end, you will gain here how much marks? 5 marks. Here how much marks? 5 marks. Here 7.5 marks. 7.5 marks. Here actually around 4 marks maybe, right? 4 marks. And the main ලකුණු ඔක්කොම direct marks are 5 plus 5 10, 10 17.5, 17.5 21.5. And also don't forget the MCQs. You will get MCQs from these all things around maybe 50. Within the next month end, you will have collected 32.5 and 36 point, 37 points. Right, here 36.5. The bindu indanga, this is from 0 level. 0 level to 36.5. You can increase your marks within the next month end. This is organic. We go into kinetics. We go into what you call industrial. We have electrochemistry. We have electrochemistry. There is no connection with other units, so we can go like that. Hurry then. Thank you for joining now. You can sleep now if you want, or you can work until like 1 or 12 something, and then have a nice sleep, have a 6 hours sleep. That is the first MSQ which you are doing, and then we are going to have the next MCQ next week. Probably focusing on structure and bonding, and there will be more questions than this. I'll include more questions than this. It will be more interactive. It's going to be fun. Hari. Have a nice day. Good night, and have a nice day. Let me have a nice night. Good night. Okay. I go. Now I go and on the email. Yes, people. Bye bye. Bye bye. Mhm.